Alright, so it's a little bit messy, but I wanted to do a quick video. It's been a little bit fun. So I'm just working on my MPCNC enclosure. I got to a point where I had a few too many wires and a few too many things, so I had to build something a little bit bigger. It's still a work in progress, as you can see, but the biggest addition was the VFD. So the VFD was exciting, interesting time to find all the different write-ups and things that people have, and I'll probably try to do something similar, just trying to put all the different things I found into one area, one guide, because I did steal little snippets from different places, and from some of them I ended up hooking up a few things a little bit differently, and just why I did that. So from the VFD, we can see, I'll just go over the cabling quick. So this is the, I got a 110 VFD. It was just easier in my garage. I know that 220 is not that hard to install, but I had limited circuits and just decided that 110 was going to be a lot simpler. So I've got my 110 line in, going to then the spindle on this side. So these are the two grounds just connected over here. So I did run 4 wires, shielded 4-wire cable out to the spindle. I'll put some strain relief on that and take some of the load off that wire when I get it out there. But yeah, that's 16 gauge wire out to the spindle. So there's my water cooled, ready to connect, ready to go spindle. So hoping to get it out in the garage tonight. I'll just run over here, mind my mess. So this is the mount I'm going to start with. I did take the 65 millimeter mount and just modified it slightly. I've got a little laser engraver, so I just put a little mount off the side of it so I can clip the laser engraver onto it. I know there's some files to put it inside, and I think if I'm going to do a lot of lasering, I probably will, but for like a lot of times I'll just do a quick laser engrave after a carve, and I find this way easier than pulling the spindle. But if I'm going to do a lot of laser work, having the spindle out to save the weight is a good idea. But yeah, I'm going to start with that mount. I know there's a few different mounts. I'll zoom in on that. A few different mounts, but I thought I'd start there and see how it goes. So this is a PLA Pro. So it's a little more heat resistant than some, but the garage is also not heated, so I'm not too worried. As well, being water cooled, I shouldn't have much of a problem with heat and stuff. So yeah, my biggest challenge was just getting the VFD. I wanted it to be software controlled, so turn on with M3, turn off with M5, spin up and spin down time, and so that took a fair bit of research and figuring. Wiring, this kind of wiring isn't my strong suit. But as we can see, basically what I ended up with is on the VFD, I've got 4 main connections. So those are just grounds. I've got 2 grounds, the black wires. The big one is the AI one, I can't quite remember, and then X1. So X1 on this VFD, so X1 through 4 are programmable switches. So in this case, X1 is linked to run. So when you trigger X1, it just turns the spindle on, and then there's a PWM signal fed from my board. So this is the PWM signal here, runs from the board into this PWM to 10 volt converter that goes into the VFD. So the relay up here is what turns the spindle, sets the spindle on off for run, and then the voltage converter is what actually controls the speed. So if I go onto my device, and I go to spindle, I can pick an RPM here. So we'll pick 9,000. So the relay clicked on, the converter is running, and clicks the VFD on, and we've got a light spin on the spindle. So that all seems to work just perfect. I've got to mess with the screen. That's supposed to be RPMs. I think that's 6,200 RPMs. but if I cycle through, that's hertz. So it's 166 hertz. So it's about right, but I think I'm going to order a tachometer and just double check the speeds I'm getting, because those can be adjusted and tuned. But if I do go over here and I switch this up, I'm just going to run it for a second, but ramp it up to 24. You can hear it pitch change. I'm going to turn it off, come back here, go off, and it turns it off and ramps down. So that means that when I'm running my G-code, I can, and you can see the spindle is the run light's no longer on. It shut itself down. So yeah, I'm excited to have that running. I also, like I said, I ran 4 wires back to the spindle, so I do have a ground back to the enclosure. So what I should be able to do is on my Z probe, when I'm probing, I should be able to probe the aluminum plate. This guy here should be able to probe without needing anything on the bit. So there's continuity between this plate and the spindle. So I shouldn't have to worry about having the magnetic end anymore. So that's kind of cool. We'll see how that works. And then one other addition that I've hopefully going to get running, I got it wired up, we'll see how it works, is just a tool depth, or a tool, like a tool setter or tool height gauge. So this was sort of the proof of concept. It's just a micro switch printed inside this body, and a little cap that you'd put a metal plate on the top, and then that would trigger the height. So I'm actually just printing a new thing on my 3D printer. I've bought 2 of these. So it's a Voron mod, and it's that little silver housing right there. And so I'm printing just a piece to go on the spoil board. So this can actually be that. So it has a metal top on it. It's a really good micro switch. So I think that will actually ultimately be a better and more accurate height gauge. So I'm going to play with that a little bit, see if I can get that working. And then lastly, on the second relay, I've just got an extra plug coming out the back of the box that I'm going to use for the water pump. So the water pump is here. I got some coolant. We'll get that figured out and sorted. But yeah, got a few things to do, but I'm excited. All right, so I'm going to cut it here, and hopefully the next step will be getting it all mounted and set up in the shop.